Hello, welcome to Space Teams University. My name is Greg Shamatoff. I'm a former astronaut. I'm also professor in aerospace engineering at Texas A&M University, and also the CEO of SimDynamics. SimDynamics and Texas A&M built this platform, Space Teams Pro, together over many, many years. And this is the first time we're running Space Teams University, which is basically a university level challenge that's using the platform as the way to simulate and demonstrate your designs. So SimDynamics and Texas A&M University have worked on this for years to build this platform. Texas Space Grant, which is a NASA-funded body for STEM in Texas, is supporting the competition. And also Mars City Design, which is another organization that has done Martian architecture design competitions for years, is also part of the partnership. This program is already used extensively for STEM programs for middle school and high school. And this time is the first time we're doing it as a university level competition. So thank you for participating. And along those lines, keep in mind that it is sort of a beta version of this software. So we're really happy to have your comments and suggestions and requests, and we'll do our best to keep up with you and provide help that you need. We know how to do everything using the platform, but making it completely user-friendly for really advanced and custom things that you will hopefully be trying to do is really the challenge. And we value all the input that you can give us during the time that this competition is running. So what is Space Teams? What is Space Teams Pro? Basically, it's a digital twin of the whole space environment. This picture behind me here is an actual picture, but you would hardly tell the difference in Space Teams Pro. The whole solar system is modeled, the planetary surfaces, accurate lighting, environmental models, gravity, and orbital mechanics. All these things are modeled very accurately in terms of the physics. And also, it's a platform for integrating your designs, your systems, the systems that comprise a spacecraft or a habitat or any robots or spacesuits. Anything that's part of an end-to-end mission is something that can be incorporated, including the dynamics and the behaviors of those objects, entities. And in combination with the space environment, basically allows you to simulate any mission. And even more than that, you can be in the mission. So you can jump into virtual reality and experience it firsthand. So that's basically what Space Teams is. And the goal of it is really to be able to do mission design, simulation, analysis, designing the mission and the operations of the mission before you actually go, before you actually spend money on the hardware. And then also supporting training and even real-time operations using the software connected to actual telemetry. So I have a video to show you this. We'll give you a really good idea of what Space Teams Pro can do. And that should give you a lot of ideas of the kinds of things that you can try to do with it as part of this competition in designing your own mission scenario or concept of operations. We call it ConOps. All right, I'm going to play that video and then talk to you more on the other side.
Space Teams is a platform and a new paradigm that enables anyone to collaborate on aerospace systems and mission design. Space Teams provides a high-fidelity virtual environment of anywhere in the solar system for the design, simulation, testing, and analysis of human-in-the-loop multi-user missions. It can be used for strategic planning, operator training, scenario-based analysis, and to support real-time operations, including situational awareness as well as virtual engagement. The Space Team's vision is to enable scientists, engineers, and students to share ideas and to contribute to humanity's future in space, while government, industry, and academia can collaborate on open or secure aerospace programs. With high-fidelity, mathematically accurate models of real physical systems, Space Teams provides the tools for engineers and operators to evaluate their systems in a precise virtual version of the intended environment. Space Team simulations can also import any user-provided models, such as CAD, environment models, or system behaviors or algorithms, to create virtually any mission scenario imaginable. In industry, it is often difficult to have different engineering teams collaborate on a single platform. The use of different software platforms often requires the work be redone or simplified. Space Teams avoids these issues by providing the interfaces and integration of all necessary files and tools in one package, including industry standards like NASA Spice Ephemeride data and APIs for Python, C++, Trick, ROS, MATLAB, and other programming languages. Users can plug in their own models or algorithms, while Space Teams provides a precision operational environment. In this example, the Earth, orbital mechanics, attitude sensor, and camera models, as well as thruster performance, is all provided by Space Teams, while the customer has plugged in their guidance, navigation, and control algorithms. Space Teams is also compatible with multi-user human-in-the-loop simulations as well as operations. Mission planning and analysis can be done fully virtually, saving time and money, and that the same capabilities carry over to the actual mission. From the cockpit, spacesuit, habitat, or mission control, all operators maintain situational awareness through mixed reality interfaces such as displays, AR, or VR. In this simulation at the rim of Shackleton Crater, the accuracy of the lunar terrain, solar lighting, and deep shadows make it possible to experience realistic operational conditions. Inside of the habitat, or in the spacesuits or in the rover, resource models are tracking utilization, storage, and generation of all resources, such as power, water, and oxygen. The mission environment is rendered seamlessly within the rest of the solar system. A user can travel anywhere and discover the other events that are happening elsewhere simultaneously and within the same simulation. Space Teams hopes to spur creativity and innovation by providing a simple way to design, build, and test models for current and future space missions. What's possible is only limited by the user's ingenuity. Space Teams Academy is a STEM version of Space Teams that is targeted for middle and high school students. The Academy version encourages innovation and teamwork through a virtual competition to design and execute the best mission to another world. Thousands of students from 15 countries around the world have already participated, and a NASA-funded grant plans to reach more than 10,000 students within the next few years.
Okay, well, that last part was part of Space Teams Academy. That's a STEM version for middle and high school students. And Space Teams University is the version you're going to be using, and that is for obviously university level, even grad level design, where you can bring in and design anything custom. You can use other tools to design your systems and import them directly in. So what are you doing for this mission? Well, you're designing a Mars city design, which can be sort of a colony or an advanced habitat. Maybe not the first one, but a little more sophisticated one, a little further on, but not too far in the future. And once you integrate that into Space Teams Pro and it's on Mars, then when we evaluate it, we're going to be looking for a number of things. Like, first of all, the architecture, how visionary your architecture is, what kind of innovations that you have in your overall city or habitats or systems that are supporting the city. Are you integrating with the environment? Does it make sense? You know, you're on Mars. Are you, is your design accommodating the Martian environment and taking advantage of it? Using in situ resource utilization, ISRU, to access the resources in the Martian environment, you know, for life support and other things. And is it a dynamic demo? You know, it could be a static demo of just assets that you created elsewhere and brought in and set up in that particular location. But it can also have robots and vehicles and crew members and solar panels and various things going on. And you're able to program all that So how complex is your scenario? How deeply did you go into demonstrating the way it's all going to work? And then finally, you're going to have a concept of operations to explain. What is your base? What's the concept? How does it work? How does it support a certain number of people living on Mars? And how does it get its resources and manage its resources for long-term sustainability? So we're going to ask you to give us a short write-up to explain your design, and then we're going to actually go into VR and walk around and check out your design as part of the judging process. There's a couple of things that you have access to that should help. So there's a folder that you're going to have access to that has some getting started documentation in it, has some videos, and it also has some links that you'll find in the document. It takes you to a wiki where you can find a forum, ask all your questions, find answers that others have posted there. Our team is going to be watching that and responding. I'm sure other people who are working on things will also post and tell you what they did. So definitely check that out. If you really need to reach us directly, you can write to support@simdynamics.com. That's SIMDYNAMX.com. That's really just for direct communication, not for problem solving, not for technical help. Use the forum for technical help. That's where our team is going to be providing that. Also, within the ST Space Teams platform, we've put a reference mission in there for you to check out, and we're going to keep updating it throughout the course of the competition. So we have a simple habitat in there, some devices, robots moving around outside the habitat, and you can take a look at our code and see how we did that, and then kind of copy it and add your own systems to that to do more complicated things. And depending on your questions and depending on the things that you're trying to do, you and all of the other teams, we will be adding some video demonstrations and adding more to the reference design throughout the next 6 weeks or so. So you can see examples or see by example how to do these things. So be sure to check out the Getting Started document, because that's going to have links in it to all the places you are going to need to go and all the information that you need to get started. So that's pretty much it to get you going. Check out all the files and the videos in the competition folder, and good luck.